what up, what up? This is a video designed to get you ready for the AP Precalculus Unit 1 Progress Check B exam given on AP Classroom. I don't do a whole lot of reteaching in this. I just give you examples, we go over it, examples, we go over it. If you want some type of reteaching or anything like that or how-to stuff, check my channel. Tons of videos called Reteaching, goes over everything. There you go. But this video is designed to get you ready for the multiple choice portion and the free response portion. And if you look through this and get everything on here, you'll get like a 95 on the exam. Of course, these are never going to be the problems exactly on the exam. You know, it would be very dishonest for me to do that. But I give you problems similar. And if you, like I said, if you understand these things, you're going to be in pretty good shape. So right off the bat, I'm giving you a rational, and that's what most of this is about, rational functions. Degree on top is 1, degree on the bottom is 1. And my job is to identify vertical asymptotes, zeros, domain, horizontal asymptotes, and then find out where this guy right here is negative. So vertical asymptotes exist where the denominator is equal to 0. Well, the denominator is equal to 0 when x is negative 1. Now, before we do too much, let's just find out what x would be equal to make the top 0, because that's going to get me part B. And I have to look out for holes, because holes determine whether or not I have horizontal asymptotes, or vertical asymptotes, I meant. So if I have 2 minus 3x, set the top equal to 0, subtract 2, let me bring it down here, that gets me negative 3x equals negative 2, divide by negative 3, divide by negative 3, x equals 2/3. So down here, I get x equals negative 1, and up here, x is 2/3 represents what makes that 0. So since there's no repeats, since none of the zeros are the same, none of the factors have the same 0, I'm pretty easily able to say that the vertical asymptote is x equals negative 1. Okay, vertical asymptote is whatever makes the bottom 0 as long as it's not repeated on the top. The 0 is whatever makes the top equal to 0 as long as it's not seen on the bottom, and in this case, the 0 was x equals 2/3. The domain are the x values I'm allowed to plug in. What x values am I allowed to plug in? Everything, except for negative 1, because negative 1 makes the bottom 0, which makes the whole thing undefined. So I will write this out in interval notation from negative infinity to negative 1 union, negative 1 to regular infinity. Some teachers might have you say all real numbers, x cannot equal negative 1. You might see the less than or equal to notation. It's all good. It's all good. Now, the horizontal asymptote has to do with the end behavior. And the way you find the end behavior, and let me kind of rewrite out what g of x is without eliminating too much. The end behavior is found by looking at the leading coefficient up here, which is negative 3x, and the leading coefficient down here, which is x. Okay, simplify that, and you get negative 3. Now, normally I'd plug in infinity, but I don't have to do that. So the horizontal asymptote is y equals negative 3. So what I need to do with E is I need to find out where everything is negative. So I'm going to want to make myself a sign graph or a sign chart, however you view it. But first, I'm not using a calculator. I need to get a good idea of what this picture looks like. This graph, no holes, no craziness, no multiplicity. I'm just going to draw a very, 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 very basic picture based off of what I know. What I know is I have a vertical asymptote at negative 1, so I will draw that out. I have a horizontal asymptote at negative 3, so I'll draw that out. I have a 0 at 2/3, so somewhere over here, I'll draw that out. I know also that if I wanted to find what the y-intercept was, the y-intercept could be found by taking the constant divided by the constant, which is 2. So based off of the information that I have, I can draw a picture that looks somewhat like this, right? Where this will flatten out at negative 3, and way down here, that happens. Okay. My job is to find out where everything is negative. Well, according to this picture that I drew out, okay, and according to what I know, is the sweet spots in this are going to be the vertical asymptotes and the zero. The vertical asymptote was -1. The zero was, what was it, 2/3? It was negative from infinity to -1, so I will say that it was negative here. Then all of a sudden we hit a vertical asymptote and show back up here and stayed positive until we hit 2/3. So positive until 2/3, and once we hit 2/3, it became negative again and then started flattening out at -3. So g of x is negative and only negative. We're not including zeros. It's negative from negative infinity all the way up until -1, union, and then from 2/3, not including 2/3, all the way to regular infinity. Okay? So this is an example where we have degree over same degree. We were able to find all this information based off of that. All right. Let's look at another one. All right, what do we have? We have a cubic over a quadratic. So this one changes slightly from what we just did. What we're going to do is exactly what it says in A, and then we're going to see what we have to do after that. I know when it's a higher degree over a small degree, I have a little bit more to deal with, but really can't do a whole lot without factoring first. So I can rip out an x. When I rip out an x, that leaves me with x squared minus x minus 6, so that will factor further. On the bottom, I have difference of squares, so x plus 2, x minus 2. And now on the top, I have x. Two numbers that add up to -1 and multiply out to -6 are x minus 3 and x plus 2. And again, that's over x plus 2 and x minus 2. So let's see what we have. What we have is a whole living right there at -2. Okay? Because what you see on the top, you also see on the bottom the same amount of times. What you see here is a vertical asymptote living at 2, and that doesn't seem to repeat anywhere else. And we have zeros that live at 0 and +3. So part A, check. Find the zeros. The zeros are what happens when the numerator is equal to 0. The numerator is equal to 0 as long as it's not repeated more times downstairs, and 0 and 3 aren't repeated at all, so my zeros are going to be 0 and 3. My holes are going to be where x is repeated upstairs and downstairs the same amount of times, and -2 is repeated, so x equals -2. The vertical asymptotes are where you have something that makes the whole thing undefined as long as it's not repeated upstairs or downstairs. And my vertical asymptote is going to be the equation x equals +2. Now it gets bad because we are being asked to find slant asymptotes. Now the slant asymptote is going to be, in this case, some linear equation that kind of cuts through like a diagonal in our graph. We're not being asked to graph this, but if I were, the slant asymptote it kind of tells us magic stuff that happens. So the only way to do that, my boys and girls, is if we do polynomial long division. So x squared plus 0x, can't forget that, -4. We're going to divide x cubed minus x squared minus 6x, and I'll throw in a +0 for good measure. Now this won't be so bad. X squared goes into x cubed x times. Multiply x to this whole thing gives us x cubed plus 0x squared minus 4x. Subtract this entire line, which means you flip the signs for everything. And so you go away, you become -x squared. You become, doesn't really matter, but -2x, and drop down, it doesn't really matter, the +0. Now, why do I keep mumbling it doesn't really matter? because when we're finding slant asymptotes, all we need is the answer. We don't care about the remainder. That's all we need. So x goes into x squared goes into negative x squared, negative one time. And so we would multiply everything by negative one, so negative x squared. Who cares, who cares, who cares? Because we don't care about the remainder. What I know is the slant asymptote is a linear equation given to us by y equals x minus 1. Okay? Okay. This next guy is asking, describe f of x as x decreases without bound. Now, what does x decreasing without bound mean? The limit as x approaches negative infinity. The way you find the limit as x approaches negative infinity of any rational is you take the leading coefficient over the leading coefficient and simplify that. So x cubed over x squared means I have two x's upstairs and two x's downstairs to eliminate. That's just x. And if I were to plug in negative infinity, notice the air quotes, if I were to plug in negative infinity, then what's going to happen is x becomes negative infinity. Now, usually when we see problems like this, maybe we multiply by 3 or maybe it's squared or something like that. But this is just going to be negative infinity. Okay? Just going to be negative infinity. All right. I'll get rid of this. I wanted to keep it there. I was going to try to find a way to keep it there, but it's just not going to happen. It's not going to happen. All right. State the domain and the range. Well, the domain is what numbers am I not allowed to plug in? Well, I'm not allowed to plug in -2 and +2. So the domain is going to be everything but -2. So negative infinity to -2 union, -2 to regular 2 union, and 2 on. Now, what this picture looks like. Okay, and obviously I'm going to have to erase that too. I didn't want to erase it. I wanted to keep it up there so bad. But knowing the information that I have, I want to draw this picture out before I find the range just to be on the safe side. I'm going to label everything that I know that I have information about because I'm going to have to do that to find out h anyway. So before I find out the range, I just want to draw this out. Okay, so all right, I had to take a quick break there. I had a screaming child in the background. Can't have that in the video. Can't have that in the video. All right, so I don't know where I left off, but I found my domain, not bad. Before I find my range, I want to get a better picture. Okay, I want a better picture of what I have to deal with. So I'm going to use all of this information to draw a picture, and that'll kind of help me understand, do I have like any weird things going on that might make like a number not appear in the range? Okay, that'll also help me figure out h. So I'm just going to draw a picture out. That is an eraser. All right, so where does magic happen? There's a 0 at 0 and 1, 2, 3. There's a hole at -2. Okay, there's a vertical asymptote at 2. There's a slant asymptote at -1, so something that looks like this because it's a positive. Yeah, if I knew how to draw, this would look a whole lot better. So something like that happens. Okay, so my picture is going to look like this weird looking thing that goes like this. Okay, so this is what I do know. So this is definitely a 0. Okay, this is definitely a 0. My picture has to kind of follow along here nicely and then kind of go up in this curved way. Okay, then this guy, which also makes sense because the limit as x approaches negative infinity is going to be infinity, is going to start down here, something like that, and then, shoot up like right there because of that vertical asymptote. So according to this picture that I have, my range is everything. I'm allowed to plug in any number. Well, I'm allowed to get out any number that's plugged in. Now, also based off of this picture, I'm able to draw a nice little sign chart. Magic seems to happen at 0, 2, and 3. Yep, just making sure my numbers are good. From from negative infinity all the way up until 0, we're negative. From 0 to 2, we are positive. From 2 to 3, we are negative. And from 3 on, we are positive. I care about where this is positive. So I'm going to say my positive numbers are going to be between 0 and 2, but not including union. And from 3 on. That's pretty intense, that one. It's like, when a bunch of people go camping. Intense. Next one. All right, what we have here is we have ourselves negative 4x up top, and we have a quadratic on the bottom. So now the denominator's degree is more powerful than the numerator's degree, which makes things a little bit simpler, maybe. The top, x is going to be 0, kind of makes the top equal to 0, so that's my 0. On the bottom, I'm going to have a multiplicity of 2. That's going to be important. And a vertical asymptote living at 4. Okay, so let's see what we need to do. Find when h of x is equal to 0. That's just fancy talk for saying what are the zeros, and in this case, the 0 is when x equals 0. Now, when you have multiplicity living somewhere in the denominator, if it's an even multiplicity where you have no repeats upstairs, you're either expecting this to happen graphically or this to happen graphically wherever you have yourself a vertical asymptote. Now, my vertical asymptote's at 4. I need to figure out which one of these guys I have. So I'm going to draw myself a very basic coordinate plane. Magic happens at 0. Okay. Vertical asymptote at 4. Now, one of the things I can do to figure out if this starts here and then goes through there and shoots up, or if it starts up here and goes through there and goes down, is I could just pick any number in here and see if it's positive or negative. If it's positive, then my picture goes up. If it's negative, then my picture goes down. So any number between 0 and 4 is like 1. So if I plug in 1, do I get a positive or a negative value? Well, if I plug in 1, I get negative 4 up top. And if I plug in 1, then I get 1 minus 4, which is negative 3, in parentheses squared, which is 9 on the bottom. And so what it does is it gives me a negative value. So this is going to be negative here. So the picture that I have is going to look like this. And then come back up. That's a close one. And then since the multiplicity is 2, it's back down here and looks something like that. Okay, so let me clean this up a little bit. Very good. Now, I know that this happens because the multiplicity down here is 2, and the multiplicity up here, there is nothing like it. So find the limit as x approaches 4 from the left. Well, here we are coming from the left, going to 4, going to 4. Oh, no. Negative infinity. Moving from the right, we going from the right, going from the right, going from the right. Oh, no. Also negative infinity, which means the limit as x approaches regular 4 exists, and the answer would be negative infinity. Didn't ask you that, but now you know. Now you know. Describe the end behavior in limit notation. Well, whenever you're being asked to find end behavior, what you do is you take the leading coefficients of each part. All right, so I have negative 4x on the top, And my leading coefficient down here would be x times x because of the factor being squared, and that would be x squared. That simplifies out to negative 4 over x. As x gets larger, the denominator also gets larger. And when the denominator gets larger and 4 stays the same or negative 4, it doesn't really matter. This whole thing is going to limit out at 0. So as it goes to the left, as it decreases without bound, as you start plugging in really small numbers, your limit's going to be 0. Similarly, as you get bigger, as you move to the right, as you plug in really large numbers, as it increases without bound, it's also going to hit 0. Fun fact, if the denominator's degree is bigger than the numerator's degree, it's going to be 0. So we could say that the limit as x approaches negative infinity of h of x is going to be the same as the limit as x approaches positive infinity of h of x, and both cases are going to be 0. Okay? Both cases are going to be 0. So the domain. The domain is going to be everything but 4. So negative infinity to 4, union 4 to infinity. All right, the next part, find the range, is kind of difficult. I regret doing it. I mean, basically what this picture is doing is it's showing up here. It's going through a little bit, and then it just starts to flatten back down. So you really can't do this without the use of a calculator. So the range is going to be like negative infinity up until whatever little bump it is right up here that you can't see, that's so microscopic. In reality, our range would probably be from negative infinity to whatever you get when you plug in like negative 0.00001. So I'm going to avoid this part because I kind of regret saying range. So you know what? I have an idea. Oh, yeah, I like it. All right, well, what do we got? We've got ourselves rational multiplicities and stuff like that. So what we need to do is we need to figure out wholes, vertical asymptotes, 0, multiplicities, stuff like that. You've got a 3 and a 3 here. Okay. Now, since the numerator is 1 degree more powerful, it's going to be a whole and not a vertical asymptote. Now, this will go through 0, but it'll be a whole at 0. So I'm not allowed to call it a 0, so I'm not going to put a big Z there. What I have here is the multiplicity of x plus 1 in the denominator is 1, actually 2 degrees higher. So at negative 1, you have yourselves a vertical asymptote. At 9, you have a vertical asymptote. And at negative 5, you have a 0. So the only 0 exists at negative 5. Now, again, you might want to think that since there's one more up here that there should be a 0 here. No. Close. Like the graph is going to appear to go through 3, but it can't ever hit 3 because you're not allowed to plug in 3. So the only legitimate x, or 0 rather, is x equals negative 5. The only whole that I have is when x equals 3. The two vertical asymptotes that I have is x equals negative 1 and x equals 9. And for what it's worth, since this multiplicity, when all is said and done, is going to be 2 times higher if I were to simplify, it's going to look something like this, or the other version. We saw that in the previous problem. Last but not least, estimate p of x if x is 10 billion, million. Numbers aren't good for me. That basically just means as the limit approaches infinity. So let's see how many x's we have. 1, 2, 3, 4 up here. So x to the 4th up here. 1, 2, 3, 4, 5. So basically what happens is this is going to go away. And you're going to end up with a really large number over an even bigger number to the 5th. So we're going to say it's pretty close to infinity. I'm sorry, it's pretty close to 0. I have it upside down. Sorry, there's a cat yelling. It threw me off. Oh, cats. It's a fun fact. That cat's name is 0. Named after the dead dog in that one movie with the skeleton. All right. Next problem and a location change. Welcome to Norristown, Pennsylvania at 6:50 a.m. It's dark here in October. That's all right. It's also Blue Day because that's our colors, and I'm wearing a Blue Among Us hat. That actually is my 8-year-old son's. Anyway, find where r of x crosses the x-axis. We're given this guy right here, and even though my face is covering it, this is a calculator problem. So we're going to do this solely on our calculator. We're going to graph that guy right there, and we're going to find where it crosses the x-axis, which is just fancy talk for find the zeros. All right, so finding where r of x crosses the x-axis is fancy talk for zeros. So let's find the zeros. Make sure that whenever you graph a rational function, you include parentheses around the entire numerator and the entire denominator, even if it seems too much. And you'll see what I mean in a second. So this is me typing out the numerator. Boom, 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 just like Black Eyed Peas once said, divided by. This is me being a little extra, but it's because I'm paranoid. I'm wrapping the entire denominator in parentheses, so it starts off with the double parentheses, like so. That way it doesn't think that this second parentheses is part of like the numerator or something like that. I'm always very paranoid about these TI things. All right, graph. There you have it. So my job is to find the zeros, and it looks like I only have one. So if I want to zoom in, I can zoom in. So I'll hit, not trace, zoom, to enter, and oh boy, there we go. So my 0 is going to live like right there. So I'm going to hit second trace, which takes me to calc. I'm going to find the 0 by hitting 2, and already I'm to the left of the 0, so I'll hit enter, go to the right, until I pass the 0, enter, and it looks like my 1 0 is going to be 0.714 rounded exactly like that. Now, if you're wondering, wait a minute. It looks like we have a quadratic up here. Why don't I have 2 zeros? Well, because one of these is probably going to be a whole, and that's what we're going to do next. All right, so the 0 for this one is just one of them, 0.714. Now, why 1? I think I said it in the video or in the cutaway. We got a whole, which as you can see in part B is my next guy. Now, what I could do for part B is I could try to factor this out and find my whole that way, but I'm going to use a little calculator trick to do that. Check out the video, you'll see what I mean. Okay, so now what I need to do is I am told that there is a whole somewhere, which means I have a factor downstairs that's pretty much exactly the same as a factor upstairs. So how do I find out the factor upstairs? Well, let's get rid of the downstairs and find out what my zeros are. Delete, 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 delete. So I'm just going to graph the numerator. Okay, now I could have factored the numerator, but I won't. I'm going to use my calculator to do the factoring for me. So if I hit graph, I know I'm zoomed in, so I'll probably have to zoom back out. See? So I'm going to hit zoom 6 to zoom out to normal. And now I can see my 2 factors. There's my 1 0 right there that I found earlier, the 0.714 or whatever. That guy is going to be my other 0. Now, I know I have a whole because it tells me I have a whole, which is telling me right now, you are a 3. So I have a whole living at 3. So lock that in your brain. I have a whole living at 3. And this second part is asking me to estimate the coordinate of that whole. Now, what I did, starting over, is I used my calculator to find, or better yet, factor the numerator, which is what I did here. Now I need to bring the whole problem back. Once I quote unquote factored the numerator, find the zeros, I know that I have a whole living at 3. So I'm going to bring back the rest of the problem. So here's that double parentheses, -3 plus x. That's where my whole is because my whole lives at 3, and 3 right there makes that 0. Parentheses x plus 7, double close parentheses. Now, there's the original problem that I had before. My job is to find out my hole. My hole is at some point 3 something, but here's the problem. I can't plug in 3 because if I plug in 3, it's undefined. So here's a quick fix. I'm not going to plug in 3. I'm going to go to Zoom Calc. I'm going to go to value, and instead of plugging in 3, I'll plug in 3.00001. A number that's awfully close to 3, but not 3. Hit enter, and it gives me the point 3.0001, which, you know what? I'll round off to 3 because we're estimating here. So my hole lives at 3, 1.699, blah, 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 blah. So 1.7. So about me estimating, if I were to plug in 3, I won't get 3. But if I were to plug in 3.00001, I get something awfully close to it. Is that 0.69 or 60? I think that's 60. So let me quick rewrite that out so I don't make that mistake. My eyes are bad. Right now it is 6:45 a.m. here in Southeast Pennsylvania. And it looks like that's 1.6. So I'm going to go with 1.6. And if I'm wrong, go ahead and scream at me in the comments, all one of you who might be willing to do that. All right, so the point of the hole, or the coordinate, is going to be 3 and 1.6. Oh, so close to my favorite Bible verse. But there you have it. There you have it. Now, for C, what I need to do is I need to see what happens when I use the limit as x approaches C from the left side. Not C. Remember, I said it's 6:40 a.m. 3 from the left side. So you're going to see that I have a nice little picture. You're going to see it in the video that I show you the hole where it exists. I'll show you in a second. All right, so for part C, here's my graph. And it's asking me if A represents the x coordinate of the hole, find the limit as x approaches A from the left. Well, A is going to be 3 in this case. So let me zoom in. Or better yet, let's do this because we haven't done this yet. Let me make a window where my primary focus is where x is 3. So let me do 1 and 5. So it's kind of close to 3, but not exactly 3. Graph. Here's 3. You can see the break in my graph. You can see the break in it. Now, what I know is if I plug in 3, I get nothing. But what this question is saying, what happens as I approach 3 from the left? Well, as I approach 3 from the left, I hit that coordinate that I found in part B, which was 1.6. And if I want to show that again, let's do this just to add a little extra minute to my video because, monetization purposes. A number that's awfully close to 3 coming from the left that's not 3 is 2.99999. What did I do? Did I hit the right thing? I wanted to do second trace value. Okay, yeah. So what I'm going to do is I'm going to do 2.999999999. Hit enter. And it gives me, 1.6. Just like I thought it would. Okay, so this guy from the left is hitting 1.6. From the right, it's also hitting 1.6, but I didn't ask you that, did I? So just as I predicted, it's going to approach the hole that I just found out in part B, which is 1.6. Yeah, calculators. Fun. All right. No calculator for this one, though. The zeros of a function are -3 and 2. Okay, the zeros are -3 and 2. There is a vertical asymptote at 4 and a hole at 5. All right. So zeros exist when the numerator doesn't have a hole living or have the same factor living in the denominator. So the numerator has factors where my zeros are -3 and 2. So that's going to be x plus 3, x minus 2. Since they're zeros, I'm not going to write them down here. I'm not going to worry about multiplicity for this one. We're not going to worry about multiplicity. There's a vertical asymptote at x equals 4, which means u happen and nothing upstairs repeats. And we're going to have a hole at x equals 5. So on the bottom and on the top. Write an equation made of only factors from the information above, call it P of x. Well, I should have read the problem ahead of time because I literally just did that. So there it is. There it is. Big arrow facing down there. Find the value of P of x when increasingly large numbers are substituted in for x, the heck does that mean? The limit as x approaches infinity. Now, the equation that I came up with, just factors, so let's multiply the leading terms of each. X times x appears to be x cubed. And on the bottom, I have x times x, which appears to be x squared. That simplifies out to x. And if I were to find out where x is heading when x is infinity, then x, it's just going to be infinity. So when I plug in increasingly large numbers in for x, I'm going to be approaching an increasingly large number, which is going to be infinity. Now, I know I have a slant asymptote because this is a cubic and this is a quadratic. What I also know is the behavior of my graph acts like this. So this is what I'm going to do. This is my answer for A. Lock that in your brain. Don't just erase it. I'm not going to rewrite it. You can't make me, although I could, and that would give me more time for my monetization purposes. I already mentioned that earlier. My graph behaves like this. Behaves like that. So let me rewrite it out. P of x behaves like x plus 3 x minus 2 over x minus 4, which means it behaves like x squared minus 2x plus 3x, that, minus 6 over x minus 4. Now, if I want to find the slant asymptote, what I do is I do polynomial long division and divide u from u. So I'm going to do that, which is not going to be a super bad process. Super bad, also the name of a movie. X squared plus x minus 6. X goes into x squared x times. So I'm going to do x times x, which is x squared, minus 4, so negative 4x. Okay, subtract the entire row, which means flip the signs of everything. And you get x plus 4x, which is 5x. Drop down the negative 6, which doesn't matter. X goes into 5x 5 times. Now I'm going to multiply that, blah, 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 but I'm really not going to. Because when you're finding the slant asymptote, all you want is the answer of your polynomial long division problem, but we don't care about remainders. So the slant asymptote of P of x is going to be the equation y equals x plus 5. Yeah. Okay. And now it's 9:50 a.m. Calculate f of 2. So here's g of x. If f of x is negative 2, g of x plus 1 plus 4. Okay. Well, f of 2 is going to mean that I rewrite this out and I do negative 2 times g of 2 plus 1 plus 4. Okay, so negative 2 times g of 3 plus 4. G of 3 is negative 3, so negative 2 times negative 3 plus 4 is going to be negative 2 times negative 3 is 6. 6 plus 4 is 10. Tables. So much fun. This is a quadratic function. It sure is. Use the zeros to write an equation of g of x. So my zeros are going to be 0 and 2, 0. So g of x is going to be x minus 0 and x minus 2, which I can write out as g of x is regular old x times x minus 2. For those of you who are here purists and you want to be like, I'll write that out as x squared minus 2x, be my guest. This is my video. In the words of Eric Cartman, I do what I want. Now I need to find g of 7. Should I refer to here? No, I'm just going to refer to that guy right there. G of 7 is just going to be 7 times 7 minus 2, which is going to be 7 times 5, which is going to be 35. Yeah. Write the equation of g of x after a vertical dilation of 2 and a horizontal translation of -3. A vertical dilation is basically when you take something and stretch Uppy Downey. Not to be confused with Robert Downey, Iron Man. Robert Downey Jr., I apologize. A vertical dilation is going to look like this. In this case, g of x times 3. Oh, I want a vertical dilation of 2. Looking ahead. 2 times g of x. And then after that, we are going to translate it horizontally, -3, which means I'm going to add 3 inside the parentheses. So putting that all together, 2 times g of x plus 3. Okay, g of x was this guy. So 2 times g of x plus 3 is going to be x plus 3, x minus 2 plus 3. I'm replacing every x with x plus 3. So x plus 3 minus 2 if I were to go in order. But what that's going to end up being is 2 times x plus 3 times x plus 1. I didn't really give it a name. I didn't say call it h of x, but if I wanted to call it h of x, I could have called it h of x, but I didn't. Again, it's my video, and I didn't think that far ahead. I do what I want. What I wish I didn't do is included this problem in the video, because this is a gross, terrible mess. I'm going to use Pascal's triangle, binomial expansion, and all that stuff. I need to go 8 levels. So kind of like the 8 circles of hell. All right, so what I did with this one is I'm being cheap, and I'm just going to paste a picture of Pascal's triangle onto the screen. There it is. Thank you, whatever website I stole this from. And this one's perfect because degree 8 happens to be right there. So that is my degree 8. Now, when you use Pascal's triangle, all right, and you use the binomial theorem, which I'm about to use, you go left to right. These are your coefficients, and then you do u to the 8th, u to the 0th, then u to the 7th, u to the 1st, whatever to the 6th, whatever to the 3rd, and then you just go. So here we are. We have 1 x to the 8th, nothing, or 2 to the 1st, 2 to the nothing, I mean, plus 8 x to the 7th, 2 to the 1st, plus 28 x to the 6th, 2 squared, plus 56 x to the 5th, 2 to the 3rd, plus 70 x to the 4th, 2 to the 4th, plus 56 x cubed, 2 to the 5th, plus 28 x squared, 2 to the 6th, plus 8 x 2 to the 7th, plus 1, nothing, 2 to the 8th. I'm going to do all the math in my head and not look at this piece of paper over here. 1 times x to the 8th is just x to the 8th. 8 times 2 to the 1st is 18, so 18 x to the 7th, plus 28 times 4 is 112 x to the 6th, plus 56 times 8. Again, I'm not looking to the left and looking at a piece of paper with the answer on it. That would be cheap. Plus, let me see, where are we? 70 times, what is that, 16 x to the 4th? Is that where we are? 1, 2, 3, 4. Yep, 70 times 16 is going to be, of course, 1,120 x to the 4th. Plus 56 times whatever that's supposed to be is 1,792 x to the third plus 1,792 x squared plus 1,024 times x plus 256. Yay! I did it honestly and fairly. Define n of x as m of x that has a vertical stretch of 3 and a horizontal shrink of 2. A vertical stretch is when you take a number and just flat out multiply it to f of x, and in our case, m of x. A horizontal shrink is when you take a number and multiply it to the x inside the parentheses. So, since this is a shrink, usually when you do a stretch, you do 1 over that number. But since this is a shrink, we're going to sneak 2 right in there. So this guy is going to look like, what are we calling it? N? N of x is going to be 3 times m of 2x, which means just replace the x with 2x. Now let's multiply that out. I'm just kidding. Oh, I don't have a death wish. Not yet. Not really. All right, last but not least, we have ourselves a calculator problem. So I'm going to move my face back down here so I can have more space. I got this from the internet, and this is not an exact calculator problem. I mean, this is not an exact quadratic, cubic, linear, whatever. So the way I want to approach this is I'm going to graph the points and see what I have. I'm not going to go like, let's see what these guys subtract out to, and then do it again and find the pattern. I'm just going to let my calculator do all the work. Go. Okay, so for this guy, I'm going to use my calculator to figure out whether it's quadratic, cubic, linear, whatever. So first thing we need to do is we need to input our values, which is going to take us a minute. So be very careful not to make any typos, because that's the easiest thing to do. Is to make typos. Everybody makes typos. Everybody makes mistakes. Hannah Montana. So I'm just typing it in. Feel free to fast forward if you wish. Or don't. Am I missing any 7? All right. Okay, I don't see any issues there on the left side. So 0, 17.2. 31.5, 42.9, 51 points. Oh, close one. 51.6. That's a 5. Ugh. 51. See, all this typo talk, and here I am doing it over and over and over again. 57.7. 61.2. 62.3. Looks like we're peaking. 61, 57.2, 51, 42.6, 31.9, 19.0, and last but not least, 4.1. All right, so this is what I'm going to do to see if this is quadratic or not. I'm going to go to second y equals and turn on my stat plot. Okay, so I'm going to go there. I'm going to turn it on, and what I want is just a bunch of dots. I don't care what color it is, just a bunch of dots. When I hit graph, don't get a lot. So what I'm going to do is I'm going to click zoom stat, and that will show me my dots. So zoom stat, and look at that. That dot over there, I must have made a typo somewhere. So let's go to stat and see where my typo is. Oh, is that 35? Yep, that would change things. So 3.5. Okay, it's good to make mistakes. Let's do zoom stat again, and much better. Now, I purposely set this up to not make it an exact thing. But darned if that doesn't look like it's quadratic. Because it is. So that's the answer that I'm going to put for A. All right, so U became quadratic. Very good. Find an equation for the data. I'm going to use quadratic regression. So for B, I need to come up with an equation. So I'm going to hit second mode to get out of this. I'm going to go, I already have my points in, so I'm going to go to Stat, Calc, and I'm going to use quadratic regression. So hit 5. Now what I'm going to do, because this will help me out for C and D, is under Store Regression Equation, I'm going to hit vars, go to Y vars, go to function, and hit enter. And what this is going to do is this is going to store my equation into Y equals so I don't have to type out the abomination that's about to show up on my screen. And there it is. Okay, so I'm going to take this information, write it out. Okay, so we ended up with Y equals negative 4.919x squared plus 34.701x plus 1.176. Now I'm going to use my Y equals to find my max and my zero. Kill two birds with one stone. Let's go. Now that I have it written out, if I go to Y equals, I don't have to type it out because I did my vars. Fun fact, I also have my plot up there so I can see how accurate my picture is. So pretty accurate. Now what I want to do for part C is I want to find the maximum height. So I want to find the max. So I'm going to hit second, trace, which takes me to calc, and I'm going to hit 4 to find my maximum. My maximum's right there, so I'm going to go to the left just a little bit, hit enter. I'm going to go to the right just a little bit, hit enter again. And my maximum value exists at 3.5, blah, blah, blah. But the actual maximum height, which is I want to find, is going to be 62.3736. So I'm going to round that up to 374 meters. Let's write it out. All right, so the maximum height was me finding the maximum. So I had 62.374. What are we, meters? And in order for me to find out where it hits the ground, I'm going to find the other zero. Last but not least here, I need to find where this thing lands. This is where I smack the ball. This is the trajectory. That's where it hits the ground. So I need to find the zero. Second, trace takes me to calc, and I want to hit 2 to find the zero. So move to the right just a teensy bit, hit enter, cross the x-axis, there we are, hit enter, and my zero appears to be 3.0878, so I will call that 3.088 seconds. And 7.088 seconds is how long it took. So, this is Progress Check 1B. Okay, this video is designed to get you ready for the Progress Check 1B, which is like 24 questions, a couple open-endeds. This covers about 95% of it, 90% of it, and if you understand what we did here, you'll be in good shape. Okay, thanks for watching. Bye.